All right, so this is going to be our fifth chunk of 5. So we're going to finish out our chapter with this PowerPoint. So about 12 slides left. All right, so I left us off with which is heavier. All right, so, and maybe you've heard that old joke, what is heavier, a pound of bricks or a pound of feathers? And of course, if you're paying attention, you would say they're the same. But really what we're trying to get at is it depends on the density. So which is heavier, a pound of bricks or a pound of feathers? Our mind tends to go to bricks because we know that bricks are going to be more dense. And that's what we want to talk about here at the end of the chapter is density. How heavy something is for its size. Now, when we're looking at density, what we're looking at is mass. All right, so even though we're saying how heavy something is, be sure you're not looking at weight, pounds. Remember, pounds is a force, and so it's talking about gravity, whereas mass is going to be the same no matter where you go. So whether you're on the moon or whether you're on the earth, your mass will be the same. And so what density is the mass to volume ratio. Mathematically, density is a big D. It's equal to little m, which is mass, divided by big V, volume. Now, density will be independent to the amount of material you have. So whether you have 5,000 bricks or you have 1 brick, the density will be the same. Now, obviously the mass will be different, but so will the volume at the same proportion. Typically, we see metals like gold have a really high density. On the other end of the spectrum, we have gases. Something like air is going to have a really low density. So what you're going to be asked to do is calculate densities. The formula is going to tell you exactly how to do that. The density is equal to mass over volume. So what we want to do is pay attention to units here. We know the unit for mass is typically going to be grams. The unit for volume is typically going to be liters or milliliters. And so if I divide those, I'll get grams per milliliter or grams per cubic centimeter. Now, a milliliter is equal to a cubic centimeter by definition. So a cubic centimeter then, cc, is equal to 1 ml. A piece of wood has a mass of 11.2 grams and a volume of 23 milliliters. What is the density? So again, we're going to say density is equal to mass over volume. So density is equal to mass over volume. Excuse me. So we're going to plug and chug here. So a piece of wood is a mass of this and a volume of that. What is the density? Well, it's going to be 11.2 grams divided by the volume, which is 23 milliliters. Now here nothing cancels out. Grams and milliliters are different. So we're just going to write that as a compound unit. No big deal here. The numbers though, we're going to take 11.2, we're going to divide it by 23. And so we get 0.48695 grams per milliliter. Now hopefully you've already looked through these other PowerPoints and you saw that in one of those previous chunks we talked about rounding and significant figures. These are both measurements. So 11.2 would be 3 sig figs, 23 is 2 sig figs. That means I'm going to take and apply the 2 sig fig value to my final answer. The 0 is not significant, so I get the 4, and then I get 8. And then look at what 6 does to 8, it rounds it up. So my final answer then is going to be 0.49 grams per milliliter. Now, if you didn't have the units here and you're working a problem out on an assessment and I see that and you didn't have the units, that would not be a big deal as long as you have them here. And your final answer, you have to have units. Now, I do highly encourage you to keep your units all the way through because you can use those units to cancel out and see how the math is going to work out. All right, our next question. A piece of wood has a density of 0.93 grams per milliliter and a volume of 23 milliliters. What is the mass? Now, we're still going to start with density is equal to mass over volume, except I'm not looking for density this time. What are we looking for? What says a piece of wood has a density of that and a volume of this? What is the mass? I want to solve for mass. So the way I'm going to do that is I'm going to multiply both sides by volume. Over here, the volumes will cancel out. Mass will be isolated by itself, and my new statement simply says mass is equal to density times volume. And so then I'm going to go up here and say, okay, the density we're told is 0.93 grams for each milliliter, so per 1 milliliter. So you can see what I did here is I broke that unit up and I put grams in the top, milliliters in the bottom. The reason why I'm doing that is because now I'm going to multiply by volume, so times 23 milliliters. So now I can see the milliliters will cancel, leaving me with grams. So now I can go to my handy dandy calculator. I'm going to take 0.93 times 23. And again, I get how many sig figs? 2 in this value, 2 in that value. So my answer is going to get 2. And that's going to give me 21 grams. Now again, my calculator answer here was 21.39. I'm going to use the 3 to round into the 1. The 3 doesn't make any changes with the 1, so it stays the same. All right. Last but not least, a piece of wood has a density of 0.93 grams per milliliter and a mass of 23 grams. What is the volume? Well, once again, we're going to start with density is equal to mass over volume. We've already seen that we can convert this so that mass is equal to density times volume. Well, now I want to get the volume isolated. So what I'm going to do now is divide both of these by density. Density here will cancel out. Volume is now isolated by itself, and so now I can see that volume is going to be equal to mass divided by density. Now, on an exam, if we're live face-to-face and you're taking your exams in the classroom, I will give you this equation. You do not need to memorize it. You will need to be able, however, to flip this around so that you can use it in any one of these forms. But this one I will give to you. If you're at home and you're taking this test, then you probably want to write all 3 of these down if you can't figure out how to do the manipulation. When I'm looking at your answers, I don't expect you to manipulate in letters. I know some students prefer to start with density equals mass over volume. They'll plug the numbers in and then rearrange to get the answer with numbers in. And that's fine by me as well. I'm sure I'll keep up with math. It'll be fine. I don't grade you on math. I'm making sure that you did do it mathematically correct. But again, you could use several different methods of math. Here we're using Algebra 1 and we're solving with one statement and one variable. But there's other methods I'm sure you could use to answer these problems. All right, once we're here, we can plug and chug for me. That's the way I like to do it. So I'm going to put 23 grams on top. And I'm going to go ahead and put that over 1. And I'm going to do something a little funky here just to kind of show you some other ways. Here are the densities on the bottom. So that means I can take that 0.93 and simply rotate it. So remember the density is grams per milliliter. What I'll do is put 1 milliliter on top. And then I'll put the 0.93 grams on the bottom. That is a horrible looking 9. Let's see if we fix that up a little bit. There we go. And the reason why I might want to do that is now I can see grams cancel out. And my answer will be in milliliters now, which is a volume. So I'll take 23. In essence, I'm going to divide it by 0.93. And I get 24.7. milliliters. Again, I have 2 sig figs here, 2 sig figs there, which means my final answer then is only allowed to have 2 sig figs, which means it will be 25 milliliters. That is a really ugly L. There we go, it's a little bit better. All right. So the units always have to work out. That's why I like to readjust things with letters. So I can see the letters are going to work out the way they should, but then once you plug the units in, the units should cancel out to leave you with the right unit. Again, I said we're using algebra 1 here, so this is one variable and one unknown, which means if you want to get the thing you're looking for by itself, you also want to make sure it's on top. A very common mistake I see students make is they'll have the reciprocal of the answer for the volume. They will mistakenly leave the volume in the denominator instead of bringing it up to the top to solve for it. So whatever you do to one side, you're doing to the other, and then you're just going to get letters to cancel out until you're equaling the letters you want to have. Now, what are some obvious points to density? So that was mathematically how we would do it all, but what about when we're in the lab? What are some tricks of the trade? Well, the first thing you have to understand is that the lower density is always going to float on the higher density. So if you've ever seen oil and water, this is what you see when, like the rain, if you've ever heard, in the first 20 minutes of a rainstorm, that's the most dangerous time to be driving. That's because the water goes down into the blacktop and pushes the oil to the surface. So your tire then doesn't get grip because it's on oil and it slides all over the place, right? And that's because oil is less dense than water. Ice is less dense than water. We see ice cubes will float, which tells us that the mass to volume ratio is smaller, right? So less dense will float on more dense. We know that most wood is less dense than water. This is probably what led people to make the first boats out of wood, because wood naturally floats on water. Helium is less dense than air. We see helium balloons floating all the time. And of course, little kids lose their balloons and you can see the helium go way up into the air. And that's again because helium is less dense than both air, which is oxygen, nitrogen, and CO2. If you've been in Delaware for any number of time here, I'm sure you've seen the big ships going up and down the bay. They go into Philadelphia for the port. They go into Delaware City. There's an oil refinery there, so they'll be offloading oil. They'll also, like I said, go all the way up to Philly. But if you've ever been out on the bay, you've seen these big ships going up and down the bay. And according to what we're observing here, we would say that the ship must be less dense than water. Is that actually true? Of course, the answer is no. If you take a piece of steel and you throw it out in the water, it is going to sink. It's going to sink really quickly. You can use metals that are less dense, like aluminum. So if you've ever seen like a little aluminum John boat, they float on water, but does that mean aluminum is less dense than water? It does not. Okay? There's some other things going on there, like surface tension and buoyancy. These are topics we won't concern ourselves with. So when we look at density, we'll be looking at mixtures, seeing how they're mixed together, seeing one layer float on another layer. As you get into more and more complex problems, there'll be other different pieces of science coming into play. We won't worry about those as much. All right, the last topic we want to hit, and I'm going to go a little longer in this chunk, just because I do want to knock it out, and it's very much related to what we've been talking about, looking at actual problems, and that's problem solving. Most students come into my classes, and they do not like word problems or problem solving, and I understand that. You know, there's those of us that are might be referred to as being sick because we actually enjoy it. I was one of those. As a college student, I loved doing word problems for science, not necessarily for math. To do just plain old word problems in math, I did not find that fun. But to look at application problems, I did. And that's where science comes in. The laboratory does not give us numbers, right? We have to go, we have to make measurements. We have to use formulas, and we have to plug them in and take those numbers we've measured, plug them into the formulas and get answers. So you have to decide how you're going to get that answer. So there was a big component in science that's different than just doing math. But math is the universal language to explain the science, which means a lot of our problems become word problems. The chemistry book is going to give you a bunch of word problems. I picked Timberlake simply because it has plenty of practice problems for you. As you flip through the chapters, at the back of chapter 2, you'll see some questions are written in the reddish pink, others are written in black. The red ones have answers at the back of the chapter there. So, if you're really struggling with a problem, one thing you can do is just check to see your answer. How's your answer doing compared to, what it says in the back of the book there, or the back of the chapter. If you're really struggling, though, just, again, make an appointment with me and we'll help you get through this. It just takes a lot of practice to get really good at problem solving. What I'm going to do now, and if you already feel like you're a really strong problem solver and you want to tune out, feel free. This will be the last topic on the slideshow. I pushed it all the way to the back. Some people already have a system they like to use. Other people do not have a system. So if you walk into this course and you do not have any system for problem solving, then you want to stay tuned to this, because I'm going to give you a little layout here that's going to help you figure out these word problems. The first thing you're going to do, the very first step, is identifying the unknown. And that seems like a no-brainer. Yeah, exactly. I want to know what it is I don't know. But I want you to do that both in words and units that you're going to measure it in. Okay? That means you may need to read that question several times. And some people just don't want to do that. That seems like work, or it hurts our feelings. We don't feel smart. I must be stupid if I have to read this thing several times. Well, I hope you don't feel that way, because that means you just called me stupid, very stupid. Every semester I've run this course, and I've been teaching here now I've been a teacher for 14 years doing science problems. And that's officially, professionally. I was in graduate school for several years, if you read my bio. There I was a TA, which means I was teaching labs there, so I was reading the same style of problems. And guess what? As an undergrad, I looked at the same style of problems there too. So I've been doing problems for 30 some odd years of my life. And even with all that experience, if you ask me the same questions every semester as previous students, I'm still going to sit there in front of you and read these questions 2 or 3 times in some cases. That's because what I want to do is I want to pull out all the information I can. So I want to identify what's being given to me, right? I want to write that down if I need to. And a lot of times I will write it down, especially if we're sitting together or working a problem together, whether it be in a tutoring session live or whether it be in a Zoom live. You'll see me writing it down. You'll see my little hand just moving, getting it down, because you want to write down everything that's necessary. Now, as we move through the chapters, eventually when we get to gases, we're going to see that there will be unnecessary information. It doesn't matter if it's necessary or not. If you see something that's mathematically a number, period, in a question, just write it down. Even if you don't use it, it's not going to be a big deal. Now, the benefit is, up until we get to gases, if you see a number in a question and you didn't use that number in your solution, you pretty much know you're wrong. Okay? If there's a number in the question, it's got to be in that calculation somewhere to get you to the answer. Up until gases. So once we get to gas laws, that will change a little bit. That'll be the first time. And I'll point it out there as well. I'll point out to you that now unnecessary information could possibly be given. Now, so you've got all this information written down. What do you need to do next? Well, next is planning the solution. So a lot of times to plan that solution, what I like to do is look at units. If it's asking me for a length, then I need to understand what unit would be a measurement of length. So whether it be meter or mile or inch or centimeter or decimeter or decameter, whatever it is, I want to make sure I understand what unit I'm trying to get to. And then I'm going to use all the other units to try to get there. That's the heart of problem solving right there. You need to be able to break it down into steps. Now, the first couple problems we look at will be very simple. It'll be one step, no big deal. Then we'll add a step. Then we'll add another step. And before you realize it, you're doing problems that are 5, 6, 7 steps long, making different conversions, different calculations, and different relationships. And so what we want to do is focus on those units. Pay attention to how the units will help us functionally get to the answer. So even if we don't understand how we're actually solving the problem, because we understood the units and we're able to make those units cancel out, we'll be able to arrive at the correct answer. Okay? You'll be able to look up any needed information, or if it's an assessment live, I might have given you that information, right? So for instance, I'll give you a periodic table once we actually get to elements. That will relate grams and moles for us. You won't have to look that up per se, you'll have it right in front of you. But if you don't have it right in front of you, then go look that up. You can use the internet or use your textbook, maybe a handout that I provided here on D2L. That might mean you're looking up tables. You might have to look up some formulas, constants, possibly some equations. Again, if it's a live exam situation, I'll have that material for you, either printed up on the whiteboard, or actually in the test questions themselves, or as a separate handout. Now, once you've gotten through the heart and you figured out your plan, the next is simply do the calculations. So we'll run through the calculations. And for this course, for Basic Chem, for General Chem, even Chem 150, it's typically algebra. Now, the Chem 150 class, it could be calculus-based, so there might be a little bit more advanced algebra course. But for chemistry, Basic Chem, Chem 100, and General Chem, Chem 110, the requirement here, the prereq, was Algebra 1. So you know we're not going to go past general algebra, basic algebra. Once you get those calculations done, you just finish it up. But what I mean by that is simply taking care of those sig figs. You know, how many sig figs does your answer need to have? Making sure you have units. And then you want to check your work, right? Since you have units, you have some sig figs, you did a calculation, you might be able to reread that question and make sure you answered it. I can't tell you how many times I've seen it, right? A question that might be something like, how many football fields does it take to go 5 miles? And undoubtedly they'll be like 0.5. Really? 0.5. So now think about that. 0.5 football field, half a football field would be equivalent to 5 miles. And of course, right away, most of us look at that and go, yeah, no, that doesn't make any sense whatsoever. Or better yet, it'd be how many football fields, and the answer would be in feet. Again, you're not answering with the correct unit. So you want to make sure you're double checking the unit, make sure you're answering the actual question. And again, is it reasonable? You know, does it make sense? And of course, to do that, you can always look at estimates. Now, I've given us an example of problem solving. So I'm going to come back to density since we talked about density. We can say how many liters of iron have a mass of 56.98 grams. So this would be a typical chemistry style question we would get asked on an exam, right? Now, if I want to apply problem solving, the first thing I want to do is identify the unknown. What's the unknown? Well, it says how many liters. So I'm looking for liters. Identify that unknown. Volume, and it's liters. All right, what did they tell us? Well, our knowns in this case would be that we have a mass of 56.98 grams. All right, so we have a mass, and now we need to know how many liters. How do I get there? I want to plan a solution. Well, I know for density relates the mass and the volume. We just studied that. So density is equal to mass over volume. Now, do I know the mass and the volume? Well, I know the mass, but I don't know the volume. That's what the actual question's asking me. Do I know the density? Not off the top of my head, I don't. Okay, well, let's go look that up. So I go into my textbook, and I find that the density of iron is 6.98 grams per milliliter. So there we go. I now have the density. I have a mass. I just need to solve for volume. So it's going to be plug and chug. I just do the calculations here. So density is equal to mass over volume. Ergo, volume must equal mass divided by density. So now I'm going to plug that in. I took 56.98 grams. I want to divide it by the density 6.98 grams per milliliter. Now the grams are divided by grams per milliliter. So grams are going to cancel out. Milliliters is going to go up to the top. The calculator tells me that's 8.1633. Now how many sig figs do I get? Well, my mass has 4 significant figures, but my density only has 3. So my final answer then only gets 3 sig figs. And so that's going to be 8.16. 3 does what to 6? Keeps it the same. And so I get 8.16. And of course, this was left out, bad Mr. Caro, but this should be 8.16 milliliters. Right? At this point, we want to check our work. And see if we got the right answer. And of course, yes, I can tell you it is the correct answer, 8.16 milliliters, right? Hopefully that made sense. And again, I know it's an easy example. You might have some harder problems than that. Go ahead and give it a try on exams. I'm not looking for you to write out the steps, so you don't have to say step 1, identify the unknown. That's not what I'm saying to do. These are mental lists that you want to go through and make sure you're following to the best of your ability. Again, you can use those units when you're planning your solution to figure out how you're going to get to your answer. All right. And again, if you have questions, make sure you get a hold of Mr. Caro. go to the tutoring center, or you can use tutoring online, something along those lines. If you're really struggling to find resources, again, get a hold of Mr. Caro. I'm more than happy to help you out, try to figure out if I can't help you, maybe it's the style, maybe you don't like the way I talk, whatever it could be. I don't take any of these things personal. What we need to do is get you to be successful. So if that means I need to find you someone else as a tutor, then that's what we'll do. Until then, hopefully you have a great week. Enjoy the rest of your studies. Don't forget you have some assignments due, whether it's a discussion board or a quiz or some sort of check-in. Make sure you're keeping up with that. Again, if you have questions about that, contact me as well. Talk to you soon. Bye-bye.